Hello, in this video we will see about the multiplexing and demultiplexing concept. There is a multiplexer. The job of the multiplexer is to combine the different sender channel and transfer the data over a large shared medium, communication medium, or to the long distance. There is the demultiplexer at the receiver side. The job of the demultiplexer is to demultiplex the different channels which are shared on the shared medium and allocate to the receiver accordingly. Here this is the signal sources, sender 1, sender 2, sender 3, and those are the different data they want to transfer. Say for example, the data number 1, one of the channel number signal source S3, signal source S2, and signal source S1. So the data number 1 from the different signal sources are taken and transmit over the transmission channel or a large bandwidth channel. It take the different input from the different source signal. In the second round again it take the different data from the different sources, etc. So in this picture the next data will be 5 and 5 from the different signal source. The color code is used over here which represent the different source. Blue is represent the S3, green background represent the S2, and red background represent the S1. So the individual data is taken from the different source per unit of time and combined, then it transfer over a transmission channel which has the more bandwidth, so that it can transfer to the longer distance. There is the demultiplexer at the receiver side. The job of the demultiplexer is the reverse of the multiplexer. Basically there are the three techniques. First one is the time division multiplexing, is also referred to as the TDM. In the time division multiplexing, that is similar like the round robin concept. What actually happen in it, suppose these are the single signals, red, blue, then yellow and green. So per unit of time the specific amount of data is taken from the sender 1, sender 2, sender 3, sender 4, and this is the multiplexer combined the different data into the frame, and it transfer to the receiver. There is the demultiplexer at that side. The job of the demultiplexer is to send the different particular set of data, that is the red, green, blue and yellow, to the whatever receiver. TDM, time division multiplexing. Say for example, next example is like that. Here the different codes, color code are given over here. The different sender send the different data per unit of time, and multiplexer combine the different data of the different source, different sender, and generate a frame. The number of inputs is 1, 2, 3, 4, 5 per unit of time, and of this all of these things 5 unit is combined into the one frame, and that is referred to as the frame, and the frame is transferred using the shared communication device over the long distance to the receiver. See, in this concept, time division multiplexing, each and every sender has given some specific time period. In that given time period he has to send some data to the multiplexer combine the different signals or different data which are gathered from the different sender, that is the A to E, and demultiplexer doing the reverse process of the multiplexer, TDM. Basically there are the two sub approaches of the TDM. First is the synchronous DM. Say for example, this is the computer 1, 2, 3 and 4. Computer A is interested to send the 4 bit of data. Say for example, that is the AA want to send the 2 bit of data B, B, single bit, that is the C, and the 3 bit, that is the D and D. There is triple D. In it, synchronous TDM, the each and every bit is taken per unit of time. So here what happened, into the frame number 1, this A, the first B, the first C and first D is taken and generate a frame and transfer using the large communication medium or a powerful cable. Now second time A, second B, there is right now no data to the computer C, so it will be left, or there is no any data, but it is unused, no one can use it, so this is the unused. And this D is transfer and generate a frame, so A, B, blank and D, that is the frame number 2. In it there is a one unused block is available. Now for the third bit A, there is no any third bit, so it will be blank. Right now there is no any third bit available to the receiver C, so it is the blank and D. So here D is completed is transaction after the frame 3, so 2 bits, 2 blocks are unused, and the frame number 3 is generated and it transfer. Right now for the fourth bit, for A computer there is a one bit, that is the A. Then there is a no bit available or data available to computer B, C and D, so those are unused and never used by the another computer or another process. So basically the synchronized TDM, this is the problem. If any computer is not interested to send the data at particular time of period, still it has reserved its block, so that is the limitation. Second example, suppose per unit of time A1, B1, blank and D1. So A1, B1, blank and D1, this is the unused block, it is reserved for the particular process 3. A2 blank, blank and D2, so A2 blank, blank and D2, that is the frame generated and transfer. Then after A3, B2, C1 and blank, A3, B2, C1 and blank, and it is transferred. So this is the synchronized TDM. Second approach is the asynchronous TDM. Some author also refer as the statistical TDM. What happened in it? See the example: A1, B1, first bit A1, B1, blank and D1. A1, B1. So here there is no data to the computer 3. So for that the next computer will get time or get this block to transfer the data. So this unused block will not longer available. So A1, B1 and the D1. Then after A2, this is the two blanks or unused, so it will not result by the computer 2 or 3 for data flow or generating a frame. So directly A2 and D2 is available, A2 and D2 is there. Then after A3, B2, C1 and blank, A3, B2, C1 and there is a blank, so no need to use it. So that is the synchronized or statistical TDM. We will get benefit over the synchronized TDM. Here there is a comparison between the synchronous TDM and the statistical or asynchronous TDM. The example is the same, but what happened in it? A1, B1 into this synchronous TDM. A1, B1, the block is unused, so it is reserved D1, D1, then the unused space, and that is the frame number 1. Then after blank B2, then the blank D2, E2, blank D2 and E2, and this is the frame number 0. So that is the synchronized TDM, in which the blocks are reserved for the process and not used. So bandwidth problem is in it, the synchronized TDM. This thing is removed into the statistical TDM. Here this concept is shown. Frequency division multiplexing. Here the frequency are reserved, say for example radio or something like that. So this is the channel number 1, the frequency is allocated for the channel number 1 to transmit the data. If the channel number 2 want to transmit the data, so this is the frequency, highest and the lowest frequency range is given to it, and this is the channel number 3. Make sure the channel number 1 and channel number 2, between them there is a guard, so that the signal overlapping problem will not arrive. There is the multiplexer combines the different channel and transfer over a longer distance. Frequency division multiplexing, say for example those are the different frequency baseband analog signal. This is the modulator as we seen into the previous videos, and those all carrier F1, carrier F2, carrier F3 combined multiplex, and the multiplex data transferred over the large bandwidth channel. So this is at the sender side. At the receiver side the reverse process is performed. It is the filter perform or separate the data from the different combined channel and send accordingly. This is a very good example. There is the 3 telephone user, and the telephone user having the specific voltage level or something like that, that is the it operate at the say for example for voltage value. So voltage value for up to 4 and up to 4 is given to the each and every telephone user, that is the modulator, and all of the user has given a specific frequency to use the frequency. So this is the blue, and 20 to 24 frequency or the limit is reserved for the blue user. Same thing, 24 to 28 is reserved for the pink or the red user, and the remaining 28 to 32 frequency used for the green user. So all of these things is combined. So it start from the 20 and at the frequency 32, it is combined over a single channel higher bandwidth link and transfer over a longer distance. There is a demultiplexer process which do the reverse process of the multiplexing and perform accordingly. It is very good example. There is a 12 voice channel, user number 1, user number 2, 3, 4, 5 up to 12 users are there, and they operate at the particular frequency or the kilohertz. Now FDM, frequency division multiplexing. So if there are the 12 user who use the 4 kilohertz, then total FDM size or this large communication cable having the capacity at least 12 into 4 kilohertz is equal to 48 kilohertz. Same, there are the still 5 groups are there, group number 1, 2, 3, 4 and 5. So total 48 into 5 48 into 5, so it is nearer about the 240 kilohertz. So this is the group, it is the individual user, this is the group, this is the super group. Now this super group has total 10 users. So single group having the 240 kilohertz frequency, so 240 into 100 is equal to 2.5 megahertz. Means the 600 voice channel. Now this is the master group, and master group there are the 6 group 6 master groups. So 1, 2, 3, 4, 5 and 6. So 252 into 6 is equal to 16.984 megahertz. Total 3600 voice group, and it is called as the jumbo group. So this thing is also possible. Thank you very much.